Good morning, and welcome to this session about Open Services Cloud. That's the first time we go public and show some kind of ideas and how Open Service Cloud can look like. So, about me, so I'm JB. I'm working at Huawei in open source ecosystem development in Europe. I'm an Apache Foundation member, so for some of you who are working at Apache, you probably know my name. I'm PMC member for roughly 20 Apache projects today. And I'm also mentoring a lot of Apache projects. I'm also a contributor on some GaiaX activity, like the lab, the open source software working group. Just a note, this presentation, all that I'm going to show you is not hard solid, I would say. Something can change. You can participate on it, change the APIs or whatever. So just to explain what we are looking for, how it can look like. I have a quick demo to show you how it can look like as well. But nothing is in the stone. You know, you can also participate and contribute on the project. Who was at the keynote this morning? Everyone? Okay. So there are probably a lot of concepts and ideas that Brian already explained to you this morning during the keynote when he talked about digital autonomy and so on. So I will probably use more kind of direct to a point into the details what he said. When we talk about the cloud today, we have three kind of personas. The end users is you, it's me, any company that wants to use cloud services. That's the first kind of personas. We have the cloud service providers themselves. So AWS, Azure, small CSPs. And we have the software vendors. So, I don't know, MongoDB, as Brian said this morning, Kafka with Confluent, extra. Today, from an end-user perspective, from the infra to the machine learning, probably the preferred building blocks to create your own solution is to use the managed services provided by the cloud provider. Simply because it's easier. It's click and it works and that's done. As soon as you want to build something more complex, it's not as easy as managed services. So first, let's talk about the cloud users and the multi-cloud experience, as Brian explained this morning. What he said, lock in. So today, most of the solution on the cloud, we are mixing managed services from the cloud provider, but also all the services they can build on top of that. And a solution is actually a mix of both. The issue is, if we use Lambda on AWS, for instance, it's not easy to move from another cloud provider simply because Lambda only exists on AWS. So as an end user, I have only two options. The first option is to use least-common-denominator, meaning that if I'm using Lambda, I'm stuck to AWS. So it's up to me to find, I don't know, maybe VM, because VM exists in most of cloud service providers. Or I have a dedicated solution. So I bet this functionality will go only on AWS, and this other functionality will go on Azure, for instance. Another thing is for the software vendor, there are limited integration with the other system into the cloud provider. So for me as an end user, even if I'm using an image provided by a software vendor, it's up to me to manage this image extra. So to install, to update, to check the security, to install extra. Now about the software vendor. For them, there are only two options to provide a managed service. And it's not a managed service, actually. It's just a service. So to install their software on the cloud provider, they have to provide an image, as I said, or to create a SaaS, a software as a service. The issue is for the image, more than the life cycle of the image that is up to the customer to install and to manage, is also a lot of dual billing, dual console. So most of the time, you can have a console for the software, but it's not integrated in your cloud provider console. So you will have basically two consoles. For the SaaS, it's basically the same. Even if I'm using a SaaS first, you create some kind of isolated islands. Because if I use two SaaS, I will have two different consoles, I will have two different systems. And so even if you use VPCs, for instance, to communicate from one SaaS to another, it's pretty limited compared to a direct integration into the cloud provider infra. And also, there's another thing in terms of market. The software vendor is competing with the infra where it's running. Because if I'm using, let me take a very concrete example. Maybe some of you know Apache ActiveMQ. Okay, it's a JMS broker that exists from the Apache Foundation. Nobody now is providing, I would say, an external cloud managed service for ActiveMQ. But Amazon is doing that. Amazon, they provide Amazon MQ, which is basically ActiveMQ rebranded by Amazon. So if tomorrow I start a service which is based on ActiveMQ, I'm going to compete against Amazon MQ. So it's not exactly what I'm looking for. So that's also a question of market share between the software vendors and the cloud providers. So now about the cloud service providers. You can say that AWS, Azure, they don't care about other cloud providers. That's not exactly true, because today the competition between cloud providers are about the managed services they provide. So if I'm a small cloud provider, I may have to compete against the big one, but how I can provide the same services provided by AWS, for instance. If I can leverage services provided by third parties, I can provide some unique and the same software as others like AWS. What we know is today, any cloud service provider, when you have to create a new managed service, for instance, tomorrow, Azure wants to create a new managed service. They don't start from scratch. They have a set of APIs they can use to create their own managed service, between 8 and 10, depending on the cloud provider. Identity, billing, admin console, etc. This is the fundamentals API that any cloud provider uses today. But these APIs, they are not public. They are only internal to the cloud service provider. By API, I don't say that it's a very simple API. It could be complex API, it could be code, it could be SDKs, I don't know. It depends a lot on the cloud service provider. But any cloud service provider, they have today these APIs. So what we want to do with Open Services Cloud is actually allow anyone to create managed services. And it's not create a SaaS or create an image. No, it's directly integrated into the cloud service provider infra, including the billing, including the admin console, including the observability layer, monitoring, etc. How we can do that? We can describe completely what is a managed service. So we describe the artifacts needed, the integration with the APIs, VPC, identity, authentication, etc. And then, once we describe, we call a framework that translates this descriptor to the cloud provider infra. So why? First is, for users, we do real multi-cloud. So we remove the locking. For the software vendor, we can provide directly software as a managed service on any cloud. And for the CSP, we extend the catalog, because I can provide a new service out of the box without effort on my infra. I just decide to fetch the descriptor that I want. So in terms of architecture, it looks like this. So on the top, you can see I have an OCL descriptor. OCL means Open Services Cloud Configuration Language. It's the descriptor that I showed you before. Not sure, explain, I will show you just after. This descriptor goes into a gateway. So the gateway, it's running into the cloud service provider infra, and it's where you can fetch the descriptor into the Open Service Cloud runtime. In the Open Service Cloud runtime, you have the orchestrator. The orchestrator takes the descriptor, translates it to something that be able to be called with the cloud service provider APIs. So that's the purpose of the orchestrator plugin. So you have one plugin per cloud service provider, basically, because we do the binding between the cloud service provider APIs and the OSC abstract APIs. Then this plugin called the fundamentals API, and you can see that this fundamentals API are called by both the cloud service provider managed services themselves, but also by the OSC managed service. It means that for the end users, it's exactly the same. It looks the same. The end user doesn't know that this managed service has been created by OSC, by Open Services Cloud, or directly by the cloud provider. It looks exactly the same. So I'm sorry, it's probably a little bit small, but this is an example of a descriptor, of service descriptor. I will show you during the demo, the descriptor. This is JSON-based. So this is a JSON descriptor where you can find the VPC, the subnet, the artifacts, the storage, but also you have here, for instance, you have a billing. So integration with a billing system, with a different billing model. You have integration with the admin console extra. This OCL, so Open Services Cloud Configuration Language, could be a JSON by its own, but it could be also integrated as a Terraform provider. So if you are already using Terraform, you can extend your existing Terraform YAML with additional data and metadata coming from OCL with a provider. We can also have an OCL extender. So extender means that you can use infra as code, so again Terraform or CloudFormation or CloudStack or whatever, to describe additional resources into the Open Services Cloud Configuration Language. So it's two directions. The first direction is you can extend Terraform with OCL, or you can extend OCL with Terraform. Both are possible. About the orchestrator and the runtime, so it's based on Java. Right now, it's a very thin runtime, so it's based on an Apache project named Carafe, and the new version, which is Minnow. It's pretty light and fast. I mean, it's less than a second. It could be created using GraalVM also, so you can use a Substrate kind of VM to run the runtime. It supports different framework. It's very power efficient, so it's very light to start the orchestrator. So you have an example of the first run of the orchestrator there. So it takes less than a second to start the orchestrator. So it started only once. I mean, once the orchestrator is running, you don't need the orchestrator once your services are deployed. The orchestrator is just used to deploy the managed service. When it's done, you can shut down the orchestrator if you want. So the orchestrator is a service runtime, basically. So it means that you can extend the orchestrator with your own plugin. So to create a plugin, you just have to implement an orchestrator service. You can see that this is the class, where you have different methods to implement, like on register, which is when your orchestrator is starting. You have a register managed service, you have a start managed service, and you can see that for register managed service, you have an OCL location, which is the configuration language location. Could be a GitHub, HTTP, whatever. Then the orchestrator calls the plugins. So in your runtime, you can have one or multiple plugins. The plugins are really responsible of interacting with the backend system, with the fundamentals API. So here you have different options. The first thing you can see is the plugin implement an orchestration plugin interface. And so the plugin is basically the same method as you find in the orchestrator service. So you can register a managed service, you can start a managed service, etc. The main difference is, in the code of a plugin, you can do whatever you want. So for instance, you can build an image in the plugin if you want, leveraging Packer or Spinnaker, Roscoe, or whatever. I mean, nothing prevents you to use anything to create an image or to interact with any APIs in the cloud infra. So now let me do a quick demo. So the demo is not, the purpose is really to show the values of Open Services Cloud. So imagine I'm a user. I'm using, let's say, so I'm connected on any cloud provider console. So I find the classic, let's say, a service like I would like to create a VM. So I create a VM here. Okay, this is my first VM. It's now running. I can, let's say, create a database. So like an RDS that you can do on AWS. So you have a database. The main thing is I can go to monitoring. So this is my VM test running there. And I have my RDS running there, my database. I have some log. And if I go to my billing dashboard, you can see that it's fully integrated. So my forecast for this month is 30 euros because I have 10 euros for VM, 20 for the database. If I create another VM like this, okay, I have my billing is now 20 because I created a new VM. Nothing, I mean, that's the classic approach to use on any cloud provider console. So that's the first persona, I'm a user, okay? So now let's use another persona, which is, I'm a cloud service provider. Of course, the cloud service provider, most of the time, they don't have a console. They are only scripting or code to deploy services. The demo show you a console just to be easier to understand. So I'm looking at the CSP. What you can see as a cloud service provider, I have a catalog. This catalog is services that I created or services that I can add using Open Services Cloud. So for instance, I have an additional services which is Kubernetes. Or I have another services which is Rancher. So let's add these services to my end users. So I just go there and I deploy my new services. Now if I go back to my user view, you can see that now I have Kubernetes. Okay, and you can see that it's fully integrated. Okay, but I have a special view for Kubernetes. If I create a Kubernetes cluster, I have my Kubernetes version, which is very specific to Kubernetes. And so if I create a Kubernetes cluster, and let's do the same for Rancher. So you can see that Rancher is fully integrated as well. I have a dedicated view for Rancher. So here, I create also a Rancher manager. And so if I go in monitoring, you can see that all is integrated. I have a CPU load, the network load for Kubernetes and Rancher. And if I go to my billing, you can see that I have 60 euros for Kubernetes and 100 euros for Rancher. Okay, that's a way that you can enable some additional managed service for my end users as a CSP. So now let's go again as a CSP, as a cloud service provider. And so what we can do is we can fetch the cloud, the OCL, the configuration language. So I will show you how it looks like. So this is a real JSON file, okay? It's more than a simple demo. So you can see this is a descriptor for Apache Pulsar. So I would like to add to my end users, as a cloud service provider, I would like to add a new service which is based on Apache Pulsar. So here you have a descriptor of Pulsar. So you have the provider, you have the artifact, so you can see the version of Pulsar there, extra. So what I'm going to do as a cloud service provider, I'm going to fetch and register this new service. It doesn't mean that it's going to be available directly to my end users. It just means I'm going to extend my catalog with my new service. So let's do that. So I fetch this JSON file, and I add into my catalog. You can see I have a new catalog created there. It was not there before. It's Pulsar. And you can see all the descriptor, the content of the descriptor. So you can see the category, you can see it's provided by Stream Native, extra, you have a billing definition, extra. So now so my catalog contains Pulsar, but it doesn't mean that it's available for my end users. So now I would like to expose Pulsar to my end users. So I select Pulsar, and I deploy it. Okay? Now I'm back to my user view. So if we go integration, you can see that before we had Kafka, and now we have Pulsar. And you can see that it's very specific to Pulsar. You have a number of bookkeeper instance, you have a number of zookeeper instance, extra. So let's create a Pulsar broker. So you can see it's fully integrated again. There are no code, it's really in the console. So we create a Pulsar broker. It's done. If we go in the monitoring now, you can see I have full integration with Pulsar. So this is the CPU load of Pulsar. It's the same for the network here. If I can show only Pulsar. And even in the log system, it's fully integrated. So you can see that this is a log that has been created by Pulsar when I start the broker. But even that, if I go to my billing view as a user, you can see that Pulsar is also integrating in my billing system, in the native billing system of a cloud service provider. So you can see that my forecast includes the Pulsar billing. Now, the other thing that we can do is the Pulsar services that I deploy on my OSC cloud, I can also deploy on another cloud, like OTC, Open Telecom Cloud, for instance. So let's log on this time using OTC. Imagine I'm switching to an OTC console. So this time I'm not running on my OSC cloud, I'm running on OTC. But you can see that if I switch to OTC, I have my Pulsar service ready. So here, I switch to another view, I switch to another cloud service provider, but the Pulsar service will be exactly the same. So you can see we remove the locking because the user can find Pulsar on first cloud provider and second cloud provider. We remove the lockout because Stream Native can deploy Pulsar on any cloud provider. That's the value, that's the objective of Open Services Cloud. So what's the current status about Open Services Cloud? So we are working on the working group with Eclipse. Michael is there. So the working group, we already have a landing page, osc.eclipse.org. We started a POC. So we are working on the code. We are working, you saw the demo. We are working on the OCL descriptor, etc. We plan to have an Eclipse project probably by beginning of next year, January, roughly, or February, something like that. It's not, I mean, can move. I mean, I cannot say the day exactly, but that's the objective. So if you want to join, work on the OCL. So the OCL is mostly on the working group layer because it's a kind of specification. So if you want to join and your company wants to join to work on the OCL definition, that's a good timing. So the RC1, the first version that can do what I show you, is planned again for January at Eclipse. That will be the first working release candidate. Probably not including all the things. I mean, we know some challenges, especially about billing. Billing is not so easy to do. I mean, the model could be very complex, but at least we will have the first integration with the fundamentals API for the billing. The goal is really to create and deploy a couple of services on some open source stack we know, like OpenStack and OTC. That's really the target. The purpose is also to identify the gaps, so between the IDs and what we're gonna see when we're gonna implement the orchestrator. So that's the technical challenges and identify the gaps. And that will be the base release of RC1 will be at Eclipse. That's the objective. If you want to join, so the working group is there. As I said, Michael is there again. So if you want to join, have details about the working group, you can be in touch with Michael or myself if you want. You can contribute on the POC, share your IDs, technical IDs as well. Again, working on different, I mean, maybe we miss some challenges or we miss some stuff, so that would be great if you can contribute. You can spread the word, okay, if you're interested by the cloud ecosystem and contribute on Open Service Cloud. That's probably one of the unique initiatives we have on the cloud today, so that could be interesting. You can subscribe to the main list, it already exists. And we have a bird of a feather tonight at 7:30 p.m. So it's 2 hours long. with pizzas and beers and so on. So it's a good opportunity to share and to discuss about Open Services Cloud, what you think about that, probably challenges you may have that maybe we don't see yet. So that's a good opportunity. You have a link there. All right. Thank you. Do you have any questions or comments? Thank you. Good timing. Yeah. Mm-hmm. Yes. Yes. That's a good question. The pricing and the billing that you show in the JSON is the billing of the software provider. I'm the stream native. I would like to submit this Pulsar service. What I want to get back and pay back is basically what I put in the descriptor. Now, the pricing the cloud service provider would like to do on top of Pulsar is up to him. Okay, he can create, let's say I said $30 or 30 euros. It doesn't mean that 30 euros will be the price you're going to pay as a end user. Maybe not, probably not. In the demo, yes, because the demo was pretty simple. I just take the bidding and expose. But you're right. I mean, probably as a cloud service provider, I will have some APIs or internal process to say the pricing is $40, and probably my pricing will be 60 or 80, whatever. Exactly. And it's a win-win, because for the software vendor, you're gonna be paid by the cloud service provider when you deploy a service that I provide. But for the cloud service provider, he can do some kind of merging on top of the cloud of a service. Yeah. Yes. It's lower than that, because we can imagine to deploy Kubernetes using the orchestrator. So just to explain, there are no thing that the orchestrator is pretty simple today. It's basically a gateway. The complexity is more on the orchestrator plugin. So in the plugin, if you want to say, I assume that I'm going to have a Kubernetes service on my infra, and I would like to leverage Kubernetes APIs to deploy my containers and so on, you can do that. But we can also imagine, I don't want to use Kubernetes because I'm going to deploy Kubernetes through Open Services Cloud. And so in this case, in the plugin, you decide, I don't want to use Kubernetes. I will actually deploy Kubernetes via the plugin. Welcome. Other question? Yeah. Yes. Yeah. Yeah. Thank you, Gail. The both tonight is in this room at 7:30. Yeah, so just yeah, all the day.
That was a very technical presentation today. One of the things which is interesting is all regulation. Know that they have a certain kind of requirements on interoperability and other stuff, transferability, and that technology for all that to fulfill the requirements of this kind of regulation. That's always something where we may want to discuss tonight another situation that this is all there for stored cloud service providers to deal with this kind of relations in data warehouses.
Does the demo help to understand Open Service Cloud? Because that's one of the big challenges we have. Most of the time, people think, okay, Open Service Cloud is maybe a new Apache JCloud or Apache libcloud, just leveraging some kind of public API. It's not that. It's lower than public API. We want really to use the low-level fundamentals API from the cloud service providers. So is it okay using the demo? I mean, does it explain and show the objectives of Open Service Cloud? Yeah? Okay, cool. Any other questions or comment? No? All right, thank you, and see you then tonight at the Bird of Feather at 7:30.